Hello Chem 1A, this is Chapter 11, Lecture Video 2, and we're going to continue our discussion on the different molecular and electron group geometries that are possible. The next electron group geometry that we're going to talk about is when you have four groups of electrons around the central atom. This leads to an electron group geometry known as tetrahedral. And so tetrahedrals are where we have a total of four groups around the central atom. Now we have three different molecular geometries that are possible when you have an electron group geometry of tetrahedral. Now the first one, like we discussed in the last lecture video, is where all four groups are bonding groups. Now in this scenario, like in the last ones, the electron group geometry and the molecular geometry are going to be the same. So if we look at an example, right, like CF4, when we draw its Lewis structure, which looks like this, we can see that there are a total of four groups around carbon. 1, 2, 3, 4. Now these four groups mean that its electron group geometry is tetrahedral. And because all four of those groups are bonds and none of them are lone pairs, the molecular geometry is also tetrahedral. All right, so this occurs when all four groups are bonds. Now, next, we got to talk about bond angle. Now, the bond angle of a tetrahedral from bond to bond is 109.5 degrees. And as we add lone pairs, this bond angle shrinks a little bit. You can kind of see here in the picture that for a trigonal pyramidal, it's 107.5, and for a bent, it's 104.5. Those are actually specific to those molecules. So in other words, ammonia and water. In reality, it's somewhere around those values for those molecular geometries, but it's not exactly those values for other molecular geometries. So let's do another example, right? So let's do something that is NH3, right? So it has the digital image there, but if we draw the actual Lewis structure of NH3, we get this structure. Now, again, if we count our groups, 1, 2, 3, 4. Remember, when we're counting for electron group geometry, we count lone pairs on the central atom and bonds around the central atom. So we still have four groups here. This is still an electron group geometry of tetrahedral. But because one of those groups is a lone pair, the molecular geometry is trigonal pyramidal. And this one occurs where we have one lone pair on the central atom and three bonding groups. Now, the last example is bent, and this is where things can get confusing between trigonal planar electron group geometry bent and tetrahedral bent. They are two very different shapes. So that's why I prefer to call the trigonal planar molecular geometry angular and the tetrahedral one bent, because this kind of separates the two. If we look at H2O, its Lewis structure is still a tetrahedral electron group geometry because we still have four groups. 1, 2, 3, 4 groups around the central atom. But its molecular geometry is what we call bent. This occurs when we have two lone pairs on the central atom and two bonding groups. Now the bond angle here is going to be, let's say BA, is going to be significantly less than 109.5. And that is distinctly different from the tetrahedral, which is 109.5 exactly. And I forgot to include that over here. Our trigonal pyramidal its bond angle would be just less than 109.5 degrees. So as we add more lone pairs, those bond angles shrink even more. All right, so that's tetrahedral electron group geometry. Let's talk about, okay, so let's talk about where we have 5 groups, which is going to be our first expanded octet geometries, 1 of 2. So when we have 5 groups around the central atom, this gives us an electron group geometry of trigonal bipyramidal, not to be mixed up with trigonal pyramidal. So when you have 5 total groups around your central atom, you have trigonal bipyramidal electron group geometry. Now, as far as our examples go, if we look at PF5, for instance, PF5 has a Lewis structure of, and as we can see, if we look at this Lewis structure, there are 1, 2, 3, 4, 5 groups around phosphorus. This means our electron group geometry, as all of these will be, is trigonal bipyramidal. Now the molecular geometry, because all of the 5 groups are bonds, we know is also going to be trigonal bipyramidal. So this occurs when all 5 groups are bonds. The bond angles here are slightly hard to kind of understand. So I'm going to use their digital image. There are actually 3 different bond angles around a trigonal bipyramidal. So if we think about from this atom to here, this is 120 degrees. That's true for any of these ones on what we call the equatorial plane. So these all have a 120 degree bond angle. Now, there's other bond angles in this structure as well. So we have 120 degrees around all of those. We also have, and I'll just leave that one here. That's 120. We also have a 90 degree bond angle here. And this is also there and here, right? So all of these middle ones are going to have a 90 degree bond angle to the bonds up and down. And then finally, we also have a 180 degree bond angle here. So these are the 3 different bond angles that are present in trigonal bipyramidals. Other molecular geometries have slightly different angles, and we'll talk about each one as we go through them. All right, so let's do another example. Let's talk about SF4. So if we draw the Lewis structure of SF4, we get, and again, if we count our groups around the central atom, 1, 2, 3, 4, 5. Now our molecular geometry here is going to be seesaw. Now this occurs when 1 lone pair is on the central atom and 4 bonding groups are present. Now our bond angles here are all the same as the previous one. So we have 120 degrees here. This one's actually slightly less than 120 degrees. We have an exact 90 degree angle here, and we still have the 180 degree there. So still all the same bond angles. Technically the 120 is slightly less than 120 due to that lone pair forcing the 2 to kind of bend a little bit. All right, so let's look at the next molecular geometry, which is T-shaped. And so if we look at the Lewis structure here, we need to look at the Lewis structure of ClF3. And so here we have ClF3. If we look at the groups around it, we have 1, 2, 3, 4, 5 groups still. So still electron group geometry of trigonal bipyramidal. Our molecular geometry, however, is T-shaped. And this occurs where we have 2 lone pairs and 3 bonding groups. Now, the bond angle here is different from the last one. We have our 90 degree here, and another 90 degree there, technically, and we have 180 degrees there. All right, so our bond angles for this structure are just 90 degrees and 180 degrees. All right, so our last molecular geometry in trigonal bipyramidal is linear, and this occurs when we have XEF2 is an example, but it occurs many other times as well. So let's draw that Lewis structure. Okay, so here we have that Lewis structure, and as you can see, we still have 5 groups around the central atom. 1, 2, 3, 4, 5. And in this scenario, our molecular geometry is linear. This occurs when we have 3 lone pairs and 2 bonding groups. Now, the bond angle here is pretty straightforward. It's a linear molecule, so it's 180 degrees. Right?